Alright, so in this video we are going to learn how to solve systems of equations algebraically by using the substitution method. Now, what exactly is solving these systems algebraically mean? Well, we are given two linear equations, two straight line equations, and what we want to find is their intersection point. That's what it means to solve this system. So if, let's say, I'm just going to draw two lines. I'm going to draw a line like this and a line like this. We are looking for the intersection point that is right there. And since we're on a Cartesian plane that has an x and y axes, we can then pinpoint that exact point and name it using an xy coordinate system. So that's exactly what we're trying to do here. So if I was to draw, let's say, very quickly, just a coordinate system like this, and there's my x and y, here's my x-axis, and here's my y-axis. We can pinpoint that exact location where those two lines intersect, and we can find what those two lines have in common, that point. That's what it means to solve a system. Now, how do you solve it algebraically and using the substitution method? Well, substitution means, why don't we try to solve for one variable and then substitute that variable into the other equation. Now, what do I mean by that? Well, look at these two equations that we have right here. We have two lines right here. Now, we can put these both into slope-intercept form or point-slope form or even standard form, but we don't need to do that. What we need to do is we need to solve for one variable, either an x or a y. It doesn't matter. So since the x plus y equals 3 is the simpler equation, why don't we use that? And we can solve for x. So I'm going to label these equations as 1 and 2, just so that we can keep tabs on them. But we're going to say 1, and I'm going to name this 2. And we said 2 is the simpler equation, so we're going to start with 2. So we put 2 right here, and we have x plus y equals 3. Now I'm going to solve for x. So solving for x, I'm going to subtract a y from the left side and bring it over to the right side, and I get that x is equal to 3 minus y. Now what does that do for me? Well, since I know an x, I can now substitute that x into the above equation, equation number 1, and I can then solve for y and get an answer, get a number answer. So let's do that. Let's take now equation 1, there's 1, and we're going to say substitute in x. Okay, so we write number 1 equation, which is 3x plus 2y equals 9. So now we know what x is, so we can substitute that in 3. And when we substitute, we always use parentheses. 3 minus y, close the parentheses, plus 2y equals 9. Now we use parentheses because that allows us to see that we need to now distribute. We need to distribute that 3 that's outside the parentheses into both terms. So when we distribute the 3, we get 3 times 3 is 9, and 3 times negative y is a negative 3y. We then bring down the 2y, and we keep it equal to 9. Now, we could see that there's two terms that have y in it, so we need to combine like terms. So when we combine the negative 3y with the positive 2y, we get that 9 minus 1y, or 9 minus y, equals 9. Now we can solve this by bringing over the 9, like so, and we get that negative y equals 0. Now we could stop right there, or if you want to divide out the negative, we can divide the negative 1 here and the negative 1 here, but we still get that y is equal to 0. So we know that that point that we drew before, now since that was just an example to show, we'll know definitively where that point is, but that y coordinate is of that point. So now, how do we find the x? Well, since both those lines intersect, they share both the same x and y. So we can now put that y into any of the equations. So we'll choose equation number 2 since it's a simple equation. So now over here I'm going to put equation 2. There's my equation 2. and we're going to now put in our y. I should say substitute in our y. In y value. And I'm going to say either equation. I'll put that in parentheses just so you remember. We can use either equation. Okay, since we know they share that same intersection point. All right, so we chose x plus y equals 3. We know that y is equal to 0, so we're going to substitute that in. Again, when we substitute, common practice, parentheses equals 3. In this case, the parentheses doesn't really serve any purpose, but it's good practice. We see that x is equal to 3. Therefore, our system, the system's answer is 3, 0. And we can box that answer in. That is our solution. So we know that those two lines cross at the x of 3 and 0, and the y of 0. Alright, so again, we're going to solve this system of equations algebraically through substitution method. We'll choose the above equation, see equation number 1. That's already set in that it's saying that y is equal to 2x plus 3. So we can easily, since it's set up in that way, take that and substitute right into equation number 2. So we'll do like before, just so you can follow. We'll name this equation 1, and we'll name this equation 2. And we're going to use equation number 2 first. So I'll put 2 down here. And I'm going to use that equation of 5x minus y equals negative 3. And now, since the number 1 equation is already in y equals, we are going to substitute it right in. So we get that 5x minus, now this is the reason why we use parentheses. Parentheses, 2x plus 3 equals negative 3. Like so. Now that parentheses reminds us that we need to now distribute. Now what exactly are we distributing? Well, there's a negative 1 in front of the parentheses. Not just a negative sign, but a negative 1. We have to remember that because sometimes we get confused. If there's just a negative, we may forget. But since a negative 1 is there, we know that we have to distribute that negative 1 to the 2x and to the 3. So let's do that right now. It's a double distribution. So we get that 5x equal 5x. Now the negative 1 times a 2x is a negative 2x. And a negative 1 times a 3 is a negative 3. And that equals negative 3. Like so. Again, we have a 5x and a negative 2x, so we could combine like terms. They both have an x. So we get 3x minus 3 equals negative 3. Now, since we have a negative 3 on the left-hand side, we can bring that over now by adding, and we get that 3x equals 0. So we know that when we divide by 3 and we divide by 3, x is going to go equal to 0. Now that's good because that's actually a very useful number, 0. It's going to make it very easy to take that number and put it into another equation. Now we could take that 0 and put it into either equation because we know that the line is intersecting at a specific point, and they share that point, so they're going to have the same xy coordinate. So let's take that 0 and let's put it into equation number 1. So we're going to use equation number 1 now. Again, we can use equation 1 or equation 2. It doesn't really matter. In our case, we're going to use equation number 1, and we see that y is equal to 2x plus 3. 2x plus 3. We know that x is 0, so now we could substitute, and again, we use parentheses, so it's 2 times 0 plus 3, and we see that y is equal to 3. So our solution is x0 and y3, 0, 3. That will be our system of this, that will be our solution to this system of equations.